Hello and welcome to another video on my channel. In this video I am going to show you how to do a simple timing benchmarking on the expression evaluation package or the project that we were using for our expression evaluation purposes. And if you recall, we were using exp4j Java library to do the evaluation, and the way it worked was that you define a function as a string and pass it to an expression builder, and it tokenizes that, and then you set the values of the variables, and then it finally evaluates the expression and returns the numeric value of the expression. Okay, now what we want to do in terms of time benchmarking is that we want to run the evaluation of a simple function, let's say just a sine function, and 1 million times. So let's say we want to evaluate it 1 million times, and let's say we want to evaluate for 1 million points inside the 0 to pi interval. Okay, and then we want to do the same evaluation but using the built-in Math.sin function. Okay, instead of having the string sine of x, we want to use the Math.sin function. And if you recall, this when we do this, it calls the native. It has a native method from the strict math class, which uses the native libraries from the operating system. Okay. Now, in order to calculate the time it takes for executing some lines of code, you can use the systems class, which is in the core Java libraries, and call the current time in milliseconds method. Okay, and this returns a long value, so the return type is long, and so it returns the current time in milliseconds. And then basically the way you can do it very simply, it's you create a start, this should be long, so you create a start variable of type long, system.currentTime millis, and then do your stuff, run the calculation or execution or whatever, and then get the, again, call the current time millis and assign it to the variable end, for example, and the total time duration is basically end minus start, and then you can just print it, system.out.println duration in milliseconds. Okay, in milliseconds. Remember, we're calling the time in milliseconds. Now, in order to save the hassle, in my Git repository, the mathlib, in the util package, I basically put all this code inside a simple timer class. Okay, so you create a timer object, new timer, and you call the start method, and basically what it does, it calls the system.currentTimeMills and basically assigns it to a variable which is basically the start variable inside this class. Okay, and then you do your stuff and call the stop method, and what the stop method in the timer does, it calls the system.currentTimeMillis again and assigns it to the end field or end variable inside the timer class. And then you can just do a system.out.println on the timer object. What it does is, whenever you do this, try to convert an object into string, it calls the toString method in the object class. If you have not overridden that, it just calls it from the object class. But I've already overridden this this toString method in the timer class, and it basically does the same thing, duration end minus start. So it basically returns this evaluation. Okay, so let's head to Eclipse and see how we can do this. Alright, so this is our demo expression library. If you recall, we are using Maven for dependency management, and I've already added the exp4j library in the Maven dependencies. And if you look at the POM file, project object model, in the dependencies the exp4j is there. It's using the 0.4.8 version of this. And if we go to the demo X, let's create a simple class called simple benchmarking, and we want to have a main method. Okay, and the main method, what I need to do is first create my points, 1 million points, and I'm going to use an array x vals. These are my vals and x values. Okay, and I want to create a uniform distribution of these points across the 0 to pi interval. So in my math util, mathlib, if you go to the util, I have a math utils class, and it has a linspace method which returns an array of doubles, and it's a static method. Okay, and you specify the start, the end, and either the number of points and the steps between points. Now if you go with the number of points, basically it creates a uniform spacing. And the same thing, if you, instead of specifying the number of points, if you specify the step size, it creates incremental steps. It's uniform, but it checks when you reach the end point. Okay, so basically when you use this method, start, end, and number of points, the start and end are always included. But when you use start, end, and the step size, it starts with the start point and adds the step size until it reaches exactly at the end or before end. So end might not be included. Okay, that's why I have this. So I start with the double value of x and add it to my value arrays, and then increment it with the step size and check whether or not it's less than or equal to n. So when we go with this step size method, the endpoint might not be included. It depends on the start and the step size. Okay, now here in the simple benchmark, so I call the math utils. Remember, it's a linspace is a static method, so you can just, it's a class method, so you call the class. So let's go from 0 pi. If you recall, pi is in the math class, right? And for the math you don't need to add any imports because it's already in the core Java, right? So I'm using that, and the number of points 1 2 3 4 5 6, so 1 million points. And then method 1 is Math.sin evaluation, so purely numeric. So what I'm going to do is I'm going to create a timer and import it from my mathlib.util, timer 1, new timer. Okay, and if we head to this timer class, it's a very simple class. So it has 3 fields, and they have package level access, right? And they could also be private. I just set them to package level default access. So they are type line, and when you call the start method, it just calls the system current time in milliseconds. Okay, and then when you when you call the stop method, it calls the system.current time millisecond, and also calculates the elapsed time. The time has passed, so basically subtracts the start time from the end time. When you call the reset method, basically it sets the start, end, and elapsed to 0. Okay, and when you call the show method, it basically just prints out the timer duration plus elapsed time in millisecond. Okay, so if you want to see the result, you can just call the show method. But then, I personally prefer to just use, even in my main code, you write the system.out.print line. So in order to do that, you have to have a string representation of your object. So that's why I've overridden the toString method from the super class. So this green arrow means I am overriding or implementing a method from a superclass. But because it's green, not blue, green means I'm overriding from an object. Basically, I'm overriding a method that is not abstract. So if you go to object, this toString method has already a default implementation. Let's go here to object.class, and it already has a default implementation, so it's not an abstract method. That's why I get that green arrow. If it was a blue arrow, means it's overriding or implementing an abstract method, which can come from an interface or an abstract class. Okay, so green means this has a default implementation, but I'm overriding that. Timer duration elapsed 1 millisecond. Okay, and so basically you create your timer 1.start, and then we do our stuff, do evaluation. I write a for loop for double xval in xvals, basically math.sin of xval. And what I'm doing, I'm using an enhanced for loop, which is also called for each loop. If you're familiar with iterators, this behind the scenes, this enhanced for loop is actually calling the iterators and is implemented based on that. Okay, and then timer 1.stop, and then system.out.println timer 1. All right, let's run this and see what we get. So we're getting about 5 milliseconds. So if you run it multiple times, you see the results might vary a little bit. That's just because the initialization, but you can run it multiple times and take an average. So let's go with method 2, expression evaluation. Now if you remember, note that we need to create the expression of sin of x one time. So let's say string s is sin of x, and then I create an expression x. So how do we do that? So we first have to create an expression builder that calls the tokenizer, and let's do the imports from net.object under exp4j. Okay, and pass in our expression or a string, and then call the variables to tell it what parts of this expression are variables. And when you do that, you call the build when you call the build method, it runs the tokenizer and changes this expression into a fully tokenized expression. If you look at what variables method returns, it returns an expression builder. That's why we can do this kind of chaining. So chaining is okay here because it doesn't mutate the original one, it just returns a new one. And then when you run the build method, it returns an expression. Okay, now that we have this expression and it's fully tokenized, we just set the value of the variable. So we again use a enhanced for loop is xvals expression set variable for xval, and then evaluate. Now I'm just evaluating. I don't care about the return type is double, but I don't want to do anything with the return value, so I just evaluate. Okay, now in order to get the timing, I have to create another timer 2 new timer, and then timer 2.start. And when we start, after the evaluation is done, and I can actually put, because I want to compare only the evaluation time, not the time it takes to create the expression. Okay, so I put the timer here and timer to stop, and system.out.println timer 2. All right, we are all set. Now let's run this. 5 milliseconds for the numerical evaluation, for this call to the native method of sine from the math class, and about 200 milliseconds for this. So about a factor of 40 difference. So it's like more than one order of between 1 order to 2 orders of magnitude difference. Okay. Now if we increase the number of evaluation by 1 order of magnitude, the question is, does the time also scale up with 1 order of magnitude? In other words, is the evaluation time or the performance is linear? So for the first time, it went from 5 milliseconds to about 350, so increased 2 orders of magnitude. Here we went from actually I can't remember the number. Let's try it one more time. So 200 to 1600. So it's more like 1 order of magnitude. So it appears that the evaluation time for the sine, the performance of this native call, is not linear, but the performance of this expression builder and the evaluation of the expression appears to be linear, because we increased the number of evaluations by 1 order of magnitude, and the time went up by 1 order of magnitude for the expression. Okay. So the last thing I want to talk about is if we head back to the power. So this is basically the end of learning about this expression evaluation library, and as an exercise you can create a simple GUI application in Java and try to implement something like this. You have a variable text box, you set the name of the variable and set its value, and then you define the function based on that variable, and you have a box that evaluates the function at that value and prints it to this box, this result box, when you hit the calculate. When you hit clear, it basically, you can set it up to either clear the results box or all the boxes. It's very easy. Now the options for GUI creation in Java is either the 2 main options that I personally use. It's either Java Swing, and you can use, and it's, I believe it's in the JavaX package, so it's a Java extension library. And option 2 is a newer option, it's Java FX, and you can use an outside application which is called Scene Builder, so it's not inside the Eclipse. So this window builder is basically a plugin in Eclipse. But this Java Scene Builder is a separate app. And the good thing about Java FX is that it allows CSS styling. If you are familiar with if you are not familiar with CSS, it's basically the type of styling that is mostly used in HTML and web styling, and it stands for cascading style sheet. So you can use CSS, and it's very convenient in a lot of sense to do CSS styling instead of trying to do the styling to one object at a time in Java Swing. But Java Swing, in my opinion, has a better integration with Eclipse. It's way more convenient, for me at least, to use window builder in Eclipse. We will try to look at this exercise next time. So thank you for watching this video. I hope you enjoyed it, and please share and subscribe, and I'll see you next time.